Okay, so this is my obligatory 200 subscriber milestone video. Thanks everyone that have subscribed to my channel, I really appreciate it. So, I'm going to do the video on hurricanes, and this is going to be the top 5 most interesting or unusual hurricanes, in my opinion. Hurricanes is in inverted commas because I'm going to be looking at all tropical cyclones around the world that meet at least a category 1 on the Saffir-Simpson scale, and I'll explain what that means in a minute, over the last 50 years or so. I'm going to go through some terminology and then get onto the list. So firstly, tropical cyclones is the universal name for all of these storms. A tropical cyclone is an area of low pressure that forms in the tropical parts of the oceans with very distinct characteristics. It's a rotating area of heavy thunderstorms that extends well into the upper atmosphere, to the upper troposphere. And these storms are fueled by the contrast between the warm seas and the cooler air in the upper troposphere. And this is one of the reasons that you don't tend to get these further north, because the sea surface temperatures aren't warm enough. And of course, there are other requirements for these tropical cyclones, such as low wind shear, which means that the wind direction doesn't change as you go further up in the atmosphere. And other things, for instance, that the Earth's rotation causes something called an inertial force, which is a fictional force that's felt on the Earth because of the Earth's rotation, and that's called the Coriolis force, or the Coriolis force is an example of an inertial force. And the Coriolis force is important because it gives tropical cyclones the ability to rotate, and without this you would not be able to get tropical cyclones, and that's the reason they don't form on the equator. Okay, so other terminology that's important. A tropical storm is a particular type of tropical cyclone. A tropical storm is generally a tropical cyclone that has wind speeds of under 74 miles an hour. And these tend to be fairly weak systems that form over the ocean, obviously. And they tend to become more powerful storms later. Some of them will develop. In fact, quite a lot of them will develop into more powerful storms. There's also something called a tropical depression, which is an even weaker variant with wind speeds typically under 39 miles an hour. Okay, so then the nomenclature gets more annoying, because for the more powerful storms, the storms that actually have names, the designation is dependent on your geographic location. So in the North Atlantic, these strong storms are called hurricanes, and for a storm to be a hurricane, for the tropical storm to become a hurricane, it has to obtain wind speeds of at least 74 miles an hour. And this is the same for any named storm all over the world. So in the North Atlantic, they're called hurricanes. In the Pacific, they're called typhoons. And in the Southern Hemisphere, they're called cyclones, which is, again, maybe a little bit confusing. In fact, actually, in Australia, they used to be called willy willies. Before I start, I'm just going to explain some of the things I'm going to do for each one. You can see that in the top left-hand corner there's an icon, which is the colour that I'm using is one that's typically used by NOAA anyway, so it's one that you would see if you look on their website of archived tropical cyclones. This is using the Saffir-Simpson scale, so this is a category 3 storm at its maximum. So all these icons represent how strong the storm was when it was at its strongest. You might be disappointed to hear that none of these storms are especially strong, but they're interesting because they're so unusual, and all of them are record-breaking in at least some sense. So the first one is Hurricane Debbie, which, as the title suggests, was a storm that developed in the early September of 1961, and you can see the track of the storm on the image on the right here, and you can see that it started off as a tropical depression west of Africa, and then developed into a hurricane in the North Atlantic. Now, the interesting thing about Debbie is that, as far as I can tell, Debbie is the only hurricane ever to make landfall with the British Isles. And I know people talk about things like the Michael Fish hurricane. That wasn't actually a hurricane. There's an interesting story about this, actually, because Michael Fish claims that he was actually talking about something going on in America. rather than anything to do with the storm that hit the UK. But even if he was talking about the UK, that storm wasn't a hurricane. It was just a very intense mid-latitude depression. Hurricanes are distinctive because they're of tropical origin. If you look at a hurricane, if you fly through one, the synoptics are completely different. They have something called a warm core. That's what gives them their energy. Whereas mid-latitude depressions are fueled by contrasting air masses and fronts. Now, this hurricane is unusual because it still had tropical status by the time it hit Northern Ireland, and it actually did some quite significant damage in Northern Ireland. In fact, it was still a Category 1 when it hit, so it had wind speeds that were sustained above 100 miles an hour in some places of the northwest of Ireland, northwest of Northern Ireland. So it was a very unusual system. And I find it especially interesting because it managed to get so far north without transitioning into what we call an extratropical cyclone, and that's a cyclone that has characteristics that are more like a depression in the mid-latitudes. Okay, so this storm arrived on the 15th of September into just off the coast of Ireland, and then on the 16th it was said that it transitioned. And there's a bit of ambiguity about whether the storm officially became a mid-latitude depression on the 15th or the 16th. And depending on this ambiguity, depends on whether this can truly be categorised as a hurricane that hits the British Isles. And you can see in the middle image here, we actually have a synoptic picture. This picture shows the surface pressure, and it has some fronts here, and the fact that there are fronts on this picture sort of indicates that it's starting to become more like a mid-latitude depression, because hurricanes don't have fronts. That being said, you can see this sort of circular, concentric, very tightly packed isobars, which is where the hurricane is, and there are no fronts that actually go right into the centre, so that sort of perhaps implies that it's still a hurricane. And it certainly felt like one for the places that got hit by it. So anyway, this is a particularly interesting storm just because it happened to come near me, in a sense. Okay, so at number 4 we have what became Hurricane Vince. And this one is unusual because of the location it formed. I mean, you can see on the map where it did form, and this is extremely far north and extremely far east. So a very unusual place to be forming. So the storm initially formed on the remnants of what was a normal extratropical depression, which became a subtropical cyclone, which is a sort of hybrid system. It has tropical characteristics, and no one really gave it a second thought. It was a small subtropical cyclone. I mean, they're not that unusual at this sort of latitude. But because the sea surface temperatures were undoubtedly cold, I think they were only about 24 degrees, which is a good 2.5 degrees too cold for tropical cyclone development. The system wasn't named because no one expected it to develop into a tropical cyclone. And also the wind shear was too high as well. This is a part of the reason why you can't get tropical cyclones so far north. Indeed, in some ways, it's a much bigger barrier than the temperature of the sea. So no one expected this storm to develop into a fully fledged tropical cyclone, but it did, and it even became a Category 1 hurricane for a very brief amount of time, and this was in early October. So I mean, quite late in the hurricane season as well. Now, you can see that it hit Spain, and the interesting thing about this is that although Hurricane Debbie might have hit the British Isles, it was somewhat ambiguous because it was beginning to transition into a extratropical mid-latitude type storm by then. You could see on the last image there were some fronts there. But this one was definitely completely tropical when it hit Spain. So it makes it the first reliable known instant where a completely tropical system has actually hit Europe. It's never happened before, with the possible exception of the 1884 Spanish hurricane, which was an even bigger storm, but that one's not well verified. Apart from that, this is the only time that a tropical storm has hit Europe. Again, unless you count Debbie, which is a somewhat ambiguous case. And if you count Debbie, then this is the second instance. Now you can see that the storm was actually dying by the time it hit Spain, and it was only a tropical depression. So the wind speeds weren't particularly high, and the storm did more damage due to the rain than it did to the wind. I mean, it gave quite a lot of rain. No more rain than would be really expected from just a normal depression in the British Isles, though. It gave a couple of inches to some places. Nothing outstanding, but the thing that makes this unusual is the fact that it formed so far north, so far east, in such cold waters, that it sort of pushes the boundaries about what we think of being a tropical storm. I'm going to mention something now that is interesting that you might want to look up. A phenomenon called medicanes. Now, a medicane is not a tropical cyclone, but it's somewhat interesting because it resembles one. And these storms form in the Mediterranean. They're quite rare. They only form every 3 or 4 years, but occasionally they do form. And they're smaller than normal tropical cyclones, and the wind speeds will never be hurricane strength, but they do look like tropical cyclones. And often there's a saying, if it looks like a tropical cyclone, it probably is. But there are reasons that you can't categorise these medicanes as tropical cyclones. But the idea that you can have a storm that even resembles a tropical cyclone in the Mediterranean is interesting in itself. And this is why I like Vince, because it sort of pushes the boundaries between where a hurricane, well, indeed, this did actually transition to a hurricane. So of course, this was the furthest northeast a hurricane has ever been as well. That's another interesting point. But it pushes the boundaries between where a hurricane can be and where a hurricane can't. The rules about where a hurricane is even allowed to be. So this is why I like this system. It sort of breaks the rules in a sense. We have Cyclone Catarina, not to be confused with Hurricane Katrina, which hit New Orleans the following year in 2005. This one actually hit Brazil in March 2004. And March is rather an odd month if you think about the North Atlantic, but this is the South Atlantic. Now, this is all rather bizarre because the South Atlantic doesn't have a hurricane season per se, because there are no hurricanes in the South Atlantic. And the wind shear is simply too high in the South Atlantic, and the sea surface temperature is too cold for hurricanes to form, for even tropical cyclones to form of any description, so we don't get them. I mean, that's actually not true per se, because there are a few examples. Maybe that can be named on one hand, perhaps, of a few weak tropical cyclones developing in the South Atlantic. All of them tend to be depressions, so with wind speeds less than 39 miles an hour. I think one or two, maybe even just one, is a tropical storm, so wind speeds less than 74 miles an hour. None of them are strong enough to be considered analogous to hurricanes or typhoons or cyclones if you're in the Indian Ocean. Except this one. This is the first one ever to reach hurricane-type status in the South Atlantic, and so was designated unofficially Cyclone Katrina. The cyclone bit because it's in the southern hemisphere, like the Indian Ocean. So we call it Cyclone Katrina, but actually this is again a completely unofficial designation, because the Brazilian Meteorological Agency doesn't name tropical cyclones in the South Atlantic, because, again, like I keep saying, there is no, there are none. So because they don't name them, the designation is completely unofficial, and Katrina was just a name of a place that it hit in Brazil. Despite all this, of course, it was a hurricane. It was a Category 2, a strong one. It hit Brazil as a Category 1, and this was completely unprecedented. And this may, unfortunately, be one of the reasons why there were, I think, 10 fatalities of this storm. Untold property damage as well. Thousands of people were left homeless, and there was an awful lot of crop damage. So it just goes to show that if these things take you unaware, then they can do a lot of damage, although it probably would have done a lot of damage anyway. Now, the interesting thing about storms like this is that in the future, things like global warming and climate change might change the weather patterns, so we can get lower wind shear, so we can get higher sea surface temperatures, so we can get environments may be just favourable enough to merit an actual cyclone hurricane season in the South Atlantic Ocean, and some of the models do suggest that in the future we may indeed see tropical cyclones developing quite regularly in the South Atlantic. I think the model suggests that maybe in a couple of 100 years that might happen. So that's interesting. Again, it's an interesting system because it breaks all the rules. It's in a place that you wouldn't expect it to be. So anyway, that's Cyclone Catarina, and quite a devastating storm at that. Okay, so at number 2 we have Hurricane Faith, and this storm is amazing to me because it holds the record for being the most northern hurricane on record, the most northern tropical cyclone on record as well, and the most eastern one. It also has the longest record, the longest track of any tropical cyclone, which again makes it amazing. You can see that it started off the coast of Africa and ended amazingly. It lost its tropical status at the Faroe Islands, and you can see where these circles become triangles. That's where it loses its tropical status. So it was still a tropical storm when it nearly was hitting the Faroe Islands, and it was still a Category 1 storm at that. So it had winds of over 74 miles an hour, sustained. And to be so far north, to be actually further north than Britain, I mean, of course, it didn't actually hit Europe, technically, so Debbie still holds some of that title of hitting Britain at that. But the fact that it was so far north, a storm could ever even hit somewhere like the Faroe Islands is insane. And part of the reason that it could do this is because, despite the fact that it had such a long track, it didn't live for that long. You can see that where you get this sort of continuous line, where all the little icons come together, it moves slower, and then when the icons spread about, it moves faster. So part of the reason that this system was able to retain its tropical identity was because it moved so quickly, and so it could keep its core of hot tropical air by the time it got to the Faroe Islands, and this monster could still be called a hurricane. But even when it lost its hurricane status, it was still a powerful system. It actually sunk a Norwegian ship after it left the Faroe Islands. So, and its effects, its chaotic effects, were felt as far east as Russia, which is amazing that a tropical remnant can get so far east. It didn't lose identity as a low pressure area before it was hitting Franz Joseph Island, which is near the North Pole. So it finally lost its identity then, which is again amazing that it could retain its identity from the west coast of Africa to near the North Pole. So basically, this is the storm that traversed the world, although it did it in over a week, not 80 days. And finally, to cap us at number 1, we have Cyclone Agni, and it's only a Category 1 storm, so it's among the weakest of the 5 storms that I've offered. But the reason it's number 1 is because of the bizarre location that this storm is in. Now, the eagle-eyed viewers may realise that this is actually the same storm that was on the front of page of this video. Now, if you look on the left image of this particular storm, and this was where it was at peak intensity, you might spot something extremely unusual. And that line that crosses through the storm is unbelievably the equator. So basically we have a storm. It's not actually on the equator, but it's pretty damn close, and you can see that the concentric circle actually overlaps with the equator. So if you were sitting on the equator, you would be underneath it. So we actually have, to all intents and purposes, a tropical cyclone sitting on the equator. So of course you read when you read about meteorology and hurricanes and that sort of thing, one of the rules is you can't have a hurricane on the equator, you can't have a tropical cyclone on the equator. These things never happen. Well, they do, because Agni is an example of where it did happen. Now, the reason that you can't practically have cyclones on the equator is because there's no Coriolis force. You need something to make them spin, and on the equator there's no fictional force. It's a force it's caused by the rotation of the Earth, from being in the reference frame of the rotation of the Earth. So what tends to happen is that storms that move away from the equator tend to be deflected by this force, and it makes them spin. Now, when you're actually on the equator, there's no force that causes these systems to spin, and if they can't spin, then they can't retain their tropical identity. So it's surprising that such a system should exist here. Now, technically, it is true that you can't ever form a tropical storm, tropical cyclone on the equator, for the reasons that I've just said. But there's no actual rule that prevents a tropical cyclone that's already formed from moving to the equator. And this is indeed what we have here. It's very unusual, and it would never happen in all intents and purposes, because tropical cyclones tend to want to move away from the equator. That's what they tend to do. They tend to move north. But very occasionally, given the right weather conditions, they can move towards the equator. And in terms of this one, we actually have a system that miraculously is said to have actually overlapped with the equator. Now, this is somewhat unverified, and the different sources say different things. So whether the actual centre of low pressure actually overlapped, actually went into the southern hemisphere while it was still a tropical storm. Some sources say it was slightly north of the equator. Some sources say that the centre of the low pressure was slightly south of the equator. If it was the case that it's slightly south of the equator, then this is remarkable, because what we actually have is an anticyclone, in a sense, because it's actually spinning in the wrong direction. Of course, systems in the northern hemisphere spin in an anti-clockwise direction, because that's the way the Coriolis force makes them spin. Systems in the southern hemisphere, cyclones, spin in a clockwise direction, and of course high pressure areas are the inverse of the low pressure areas, so a high pressure area spins in the opposite direction. So now we have a cyclone, clearly a tropical storm, a hurricane almost, that was actually crossed the equator into the southern hemisphere and was still spinning anti-clockwise. So it was anticyclonic, but it was obviously a cyclone. So we have an anticyclonic tropical cyclone in the southern hemisphere that formed in the northern hemisphere, and this is something that is completely mind-boggling to me. So the idea is that because the system is still, because the system has momentum, angular momentum, it spins in an anti-clockwise fashion, because the Coriolis force in the northern hemisphere causes it to spin anti-clockwise. And so when it crosses over into the southern hemisphere, the momentum it has continues to cause it to spin in an anti-clockwise fashion. Of course, it will be tend to very much weaken by this point, because there's nothing to keep it going. But this is like the Medicanes or Hurricane Faith being so far north. It tests the boundaries of what we understand, and in terms of the field of meteorology, this is so amazingly interesting, because it tests the boundaries of science, of understanding, and this is why a storm like Agni is more fascinating than a Category 5 hurricane that's where it's supposed to be. You get a lot of Category 5s in the Pacific, actually. They're called typhoons there, super typhoons, as it were. So while I'm interested in the strongest typhoons ever, which was probably actually Typhoon Haiti, which was 2013 storm, probably the strongest storm on record, disputedly. But the reason I find these storms more interesting is because they're so unusual. They try to break the rules, or at least bend them. And a storm like Agni really helps us to find out new things that we didn't know before. Because if Agni had never happened, then maybe we would have just gone under the assumption that that tropical storms can never cross the equator. But now, at the very least, we know that they might be able to, or probably will be able to. So this sort of helps us advance the science and the understanding behind these systems. And to me, that's what science is all about, testing the boundaries of knowledge. And these storms epitomise that for me. So I hope you enjoyed this video. I've tried to make it as informal as I can. And I'm going to continue doing interesting science, maths, physics, climate videos when I can, and of course the bi-weekly shows, which I'll continue to be doing. So I hope you enjoyed this, and thanks very much for subscribing. And this is for all my subscribers.